All right, guys, welcome to the third part of our video, talking about the different types of electricity. And a lot of these you already know, but as we go through, you guys are going to be able to kind of find a little bit more out about them. So again, write types of electricity in your notebook. Okay. And we're going to have the first two types of electricity. The first type is static electricity, and the second type is current electricity. So remember, static electricity is an electrical charge of an object that develops as a result of having an unequal number of protons and electrons. Current electricity is the movement of electrons through a conductor. I'm going to have you pause and take notes first, and then we're going to go through and talk about them. So take notes. All right, so static electricity makes sense to you guys. You guys have talked about it, okay? Over and over and over again, right? When it gets winter out and it gets really dry out and you're sitting in a chair, you get up and move, you touch a metal and you get that electric shock. That's static electricity. You take a balloon, right? And you rub it up against your hair, and I know my awesome hair is long. You rub it, and as you do it, the balloon follows my hair. What we're talking about is an unequal number of protons and electrons. Remember, protons positively charged, electrons negatively charged. Okay, and basically the way we end up talking about static electricity is that just like a person or an animal, everything wants to get back to normal. And when we say normal, what that means is it's an equal number of protons and electrons, because again, with the magnets, we know that opposites attract. So you have a positive, you have a negative. When you put them together, they stay. Okay, so if we have an unequal number of protons or electrons, every time that we end up getting that electric shock, or the zoom between you, is basically the way of the electricity kind of resetting itself. It's shifting those electrons and protons back in order. Okay, so when we talk about current electricity, we're talking about how the electrons move through a conductor. Remember, we end up talking about conductors being things that have a loose hold in the valence level, so 1, 2, or 3, and how the electrons can bounce from atom to atom to atom. So things that are conductors, things like copper, things like metal, things like water actually can be a conductor. Okay, so that is the flow through. So when we did those examples of the electron moving from atom to atom to atom, that would be current electricity. So static, again, electricity, a little bit different, something you're familiar with. One of the things that we are going to do, and we will be working on kind of later in this, and especially when you're in person, is we're going to do a static electricity demo where we're going to be talking about how static electricity forms. And so that's going to be a video for the 100% virtual kids. I will do a video on static electricity by itself. But for those of you who are hybrid, you're going to get an in-person kind of demo with that. And part of that is also going to be something called the Van de Graaff machine, which is basically all built on static electricity. Okay, so again, that's an unequal number of protons or electrons. So where do we see static electricity? Okay, it's an uncontrollable electricity. You don't really know when it's going to happen. So I'm sitting in a chair, I rub my butt back and forth, and all of a sudden I stand up, I walk over to a friend and I zap them, right? That's static electricity. You have a really dry house and you're taking off a sweatshirt, and as you take off your sweatshirt, all of a sudden you see kind of little sparks happening. Okay, lightning is static electricity. It's kind of a buildup of too many electrons, and what happens is that sudden release of electrons trying to get back to normal. Okay, static cling. So if all of a sudden you have a sock that's hanging on to your pants, static cling happens quite a bit. That's why we have things called dryer sheets. Wool socks on a carpet. Walking back and forth, walking back and forth, walking back and forth. You find a friend, again, you shock them. That is different versions of static electricity. So I want you guys to pause, and you can take your notes on static electricity. All right, let's talk about current electricity. So in current electricity, we have two different types. We have something called DC, which is a direct current. And we're going to talk about what a direct current is right now, or just in a minute. And something called alternating current, AC, which is things we get from like a power outlet. Okay, so what I want you to do is write current electricity and the two types, direct current and alternating current. So let's go, and we're going to dive in with direct current. So actually pause, take notes here. So direct current. When we are talking about direct current, we are talking about the electrons flowing in the same direction every single time, from negative to positive. And this is something we are going to hit over and over and over and over and over again. When we are talking about direct current, we are talking about the flow from negative to positive. Keep in mind, when we've been talking about electrons and how they move from atom to atom to atom, remember, an electron has a negatively charged particle. Okay, so a negative charged particle is going to hit a negatively charged particle, negatively charged, negatively charged, negatively charged. And what they're trying to do is they're trying to get back to the positive area. So negative to positive. So what you're going to do here in a second is you guys are going to write this in. Oh, sorry. And you're going to draw in this diagram right here. Okay, so I want you to take notes. On direct current, and then that way we should be able to talk about it. So things that we get direct current from, things like batteries. So anytime you are using a battery, it could be a lithium battery, it could be a non-lithium battery, like an alkaline battery, like your Duracell batteries. Those are direct current. It goes from negative to positive. Okay, and one of the videos we're going to watch a little bit later is it's going to talk like how a battery is spaced out, that on the positive end of a battery, where the little top is, that's where all the positive charges are. Where the bottom part of a battery is, where the negative area is, that's where all the negatively charged ions are, or particles are, and how that moves through a circuit. The other thing is sometimes this can be converted from alternating current. Alternating current, as we're going to learn about in just a second, is like once we plug in to a computer, or once we plug into, to an outlet, then we can actually figure out, or something switches it to direct current. So you're going to see that I just kind of switch here, and I'm going to leave here for a second, and I'm going to show you something that walks us through how we go from alternating current to direct current. So, all right, so what I have here is two examples of alternating current to direct current, and you'll see my computer screen got really bright, so I apologize about that. But this is the part that plugs into your wall outlet, and it runs through a cord. So cord, and then you have this fancy little thing right here. This little thing right here is what converts that alternating current to direct current, and that direct current then flows through this cord to your Chromebook, laptop, anything like that. And if we look on here, this is called an AC adapter, meaning it converts alternating current to direct current. And as you're working with these, this is something that gets really hot. Okay, so as it gets hot, you kind of want to give it space to be able to breathe, right? It has all these different warnings under here about making sure you don't throw it in fire and different things like that. But if you've ever wondered what this is that little thing that converts direct current to alternating current. How does this work on, let's say, a cell phone? So on a cell phone, you guys usually have these little things right here, okay? What these little things do is you plug it in to the outlet, and then this box is your converter. It converts alternating current, which we're going to learn about in a second, to direct current through the cord that then plugs into your phone, into your iPod. I know, iPod, way old. Different things like that. I'm guessing most of you have never owned an iPod, but we can call it an iPhone. Anything that has a charger ends up having something like this, okay? When we talk about devices, most devices use direct current, okay? So that is the difference. Direct current, one direction. So for example, if I'm telling you to go to here to Kennedy's in the most direct fashion, okay, you would take a straight line. I mean, you'd have to go through houses and stuff like that. But that is a direct current. It's one path from negative to positive. So again, repeat, negative to positive. All right, so hopefully you took notes on different things that can go from there. So what's alternating current? Alternating current is the electrical current moves and changes direction, meaning it goes in one direction, then goes in the other direction, goes in one direction, goes in the other direction, one direction, other direction. Think of alternating. When two people alternate, it's one go, the other go, one go, the other go. Back and forth, back and forth, back and forth, back and forth, back and forth. Okay? So in this case, you have going one way, and then it's going to go the other way. One way, and then go the other way. So I'm going to give you a second to take those notes. Notice on here that right now we don't have a positive and negative because it moves back and forth. Things that use alternating current are things like lamps, things like fans, is they don't have to have a direct current. They can actually run off of alternating current. But things like laptops, Chromebooks, phones are going to be charged using a direct current because they have a battery that goes with it. So what are some things that use alternating current? Okay, they come from generators, coal-burning nuclear power plants, hydroelectric plants, hydro meaning water, so water plants, wind, solar generators. What are they used for? Motors, so motors that you plug into, heaters, lights, anything that plugs into the wall. Your wall comes out in alternating current, AC current, okay? I don't really have a whole lot more for that besides just the example of like if someone was walking to Kennedy's and I said alternate your path. You're going to move in a bunch of different directions in order to get there. You're going to go left, you're going to go right, you're going to go forward, you're going to go back. You're going to keep moving every which direction, but eventually you would find your way getting there. Okay. This allows for a different type of electric source and just kind of allows the electrons to move in multiple different fashions. So here's where it gets interesting. Our plan going forward is those of you who are virtual are going to be doing a different activity for this week, and those of you who are in person are going to be doing a different activity as well, and 2 different activities. One of them is going to be focusing on in-person lab, which we're going to talk about static electricity, and we're going to do something with a battery. And we're going to get a live demo of something called a Van de Graaff machine. Those of you who are 100% virtual, you're going to do kind of 2 different things, both Friday and Monday. Okay, so I'm going to kind of have that information laid out in the directions below. It's going to be a little bit confusing, but I'm going to try to make it as clear as possible. All right, those of you who are hybrid, when you're in person, you're going to be doing one activity, and when you're out of person, you're going to be doing a different activity. So with that, hopefully you understand the different types of electricity. So again, our different types are direct current, alternating current. We have static electricity. Okay, so those are all different things that we are talking about. All right. With that, this is the end of your lecture for this group of lessons. Going forward, we are going to be doing our hands-on activity for in-person, and our virtual students, you guys are going to be doing opposite activities, and then the week you guys are going to flip. So we have a bunch of information coming forward. Keep doing really well, keep paying attention, and like we said, if you keep rolling, good things are going to happen. All right.